P0303 on this 2019 to 2024 Ram 1500 Classic with the 3.6 Pentastar means the PCM is seeing a cylinder 3 misfire pattern. The PCM is watching crankshaft speed changes, and when cylinder-to-cylinder speed variation exceeds its calibrated limit, it calls that a misfire. The customer may describe a rough idle, stumble, reduced power, a flashing or illuminated MIL. And on stop/start equipped trucks, the stop/start system may be disabled while this code is active. Broadly, this can come from ignition, fuel delivery, intake leakage, fuel quality, carbon, engine mechanical issues, sensor or tone wheel concerns, harness problems, or, later in the path, the PCM. Start with the basic system checks and follow a structured diagnostic approach before getting too deep. Before chasing cylinder 3, make sure the monitor had a fair chance to run. Treat the run conditions as monitor gates: fuel level above 12%, battery voltage above 10.9 volts, ambient temperature above -23 degrees C, -9.4 degrees F, coolant temperature at engine start above -7 degrees C, 19.4 degrees F, or if start engine temperature is below threshold, the monitor enables when engine temperature reaches 21 degrees C, 69.8 degrees F, and engine speed between approximately 400 RPM and 6,200 RPM. The misfire monitor is disabled during a decel fuel shutoff event. Now turn the ignition on, pull and record all codes and captured conditions, then operate the vehicle under the same captured conditions. While driving, note exactly when the misfire shows up. Watch the downstream oxygen sensor behavior while it is happening, and use the misfire monitor to confirm cylinder 3 is the cylinder showing excessive misfires. If cylinder 3 is not showing excessive misfires right now, treat it as an intermittent condition instead of forcing the rest of this path. If the misfire is active on cylinder 3, look at the codes you recorded. If there are applicable bulletins or active or pending codes tied to fuel, ignition, air handling, or VVT, handle those first because they can drive this misfire. If none are present, the next handoff in this path is not clear. Pause there, recheck the earlier diagnostic path, and avoid guessing. Next, do a careful inspection. Look for accessory drive problems like a worn belt or pulley misalignment and binding. Check sensor mounting and connector condition around the crank, cam, map, throttle body, injector, coil, and related circuits. Also look for poor PCM powers or grounds, vacuum leaks, intake or exhaust restriction, internal engine concerns, moisture on ignition components, fuel supply or fuel quality issues, and load-related conditions like towing overload. If you find a problem, repair what you found and verify the repair. If you do not find anything, this second handoff is also unclear, so pause and recheck the earlier diagnostic path before moving on. Once the path is confirmed, check the oiling and mechanical basics. Look for engine mechanical tolerances out of specification, oil pressure out of specification, low oil level, an incorrect oil filter, deteriorated or dirty oil, contaminated oil, incorrect viscosity, or aerated oil. If any of those are present, repair the oiling or mechanical condition, including concerns such as improper oil drainback, sludge, a damaged oil pump, pickup tube, or seal, and then verify the repair. If oiling and mechanical checks pass, check the intake system for leaks at the engine and intake manifold. Repair any intake leak and verify. If no intake leak is found, move into fuel quality. Before fuel system testing or service, remember the system can stay under pressure even with the engine off, so release fuel pressure before opening any hose, fitting, or line. Check for water, wrong fuel type, old or contaminated fuel, low fuel and proper ethanol level. If the fuel is the problem, replace the fuel and, if needed, flush and clean the fuel system, then verify the repair. Next, check whether the cylinder 3 injector is clogged or leaking by comparing it to known good cylinders. Install fuel pressure decay tester 8978A to the fuel rail. Turn the ignition on, let pressure reach maximum and stabilize, then record that as the starting pressure. Actuate the injector for the misfiring cylinder with the scan tool while watching the gauge and record the ending pressure. After each injector actuation, start the engine to clear fuel out of the cylinder, skipping that can damage the engine. Repeat the same process on several cylinders that are not misfiring, always starting each actuation at the same starting pressure. If ending pressures are about the same, continue to the ignition check. If cylinder 3 stands out, a pressure drop that is too small points you toward debris in the rail or injector that needs repair. A pressure drop that is too large makes a faulty or fouled injector suspect. After that repair path, verify the repair. If the injector comparison is even, remove the fuel pressure decay tester and reconnect the fuel lines before continuing. Pull the ignition coil from cylinder 3, reconnect the coil connector, disconnect the cylinder 3 injector connector, install a spark tester on the coil, and crank the engine. If you have a crisp blue spark, move to the plug and cylinder inspection. If you do not, go to the coil power and control circuit checks. With spark present, remove the spark plug and inspect it for cracks, carbon tracking, oil, coolant, excess fuel fouling, gap out of specification, and a loose or broken electrode. Also check for oil or coolant in the cylinder. If those conditions are present, replace the spark plug, and if oil or coolant is present, diagnose and repair the cause before verifying. If the plug and cylinder look good, run a compression test on several cylinders and compare known good cylinders to cylinder 3. If compression is not within specification, use a cylinder leak down test to separate valvetrain from combustion chamber causes. Repair as needed and verify. If compression is within specification, swap the cylinder 3 spark plug with a known good cylinder that is not misfiring, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire follows the plug, replace the plug and verify. If the plug was replaced and the misfire is gone, verify the repair. If the misfire does not follow, decarbon the engine using Mopar combustion cleaner. After driving and clearing the cleaner from the engine, erase codes, test drive under the captured conditions, and watch the misfire monitor. If the misfire does not return, cleaning the valves and chambers repaired the fault. If it does return, visually inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. Repair any issue found and verify. If no valvetrain issue is found, continue to the harness and PCM connection check. If the spark test did not show a crisp blue spark, stay safe around the running engine. Do not stand in line with the fan, keep hands away from pulleys, belts, and the fan, and keep loose clothing clear. Turn the ignition off, disconnect the ignition coil connector, turn the ignition on, and use the scan tool to actuate the ASD relay. With a 12-volt test light connected to ground, probe the ASD relay F344 output circuit at the coil connector. If the light does not illuminate brightly, stop all scan tool actuations and repair the open or short to ground between the PDC and the ignition coil connector, then verify. If the feed is good, check the coil control circuit. Use a 12-volt test light connected to a 12-volt source. Back probe the coil control circuit at the coil connector and crank the engine for 5 seconds. If the test light blinks brightly, replace the ignition coil and verify. If the light stays on constantly, check the coil control circuit for a short to ground. Do not probe the PCM harness connectors directly. Use GPEC diagnostic adapter 10436. Disconnect PCM-C2, connect the adapter to the engine harness side, and check continuity between ground and the coil control circuit. If there is continuity, repair the short to ground and verify. If there is no continuity, continue to the final connection check. If the test light stayed off constantly during cranking, check the coil control circuit for an open by measuring resistance between the coil connector and the GPEC adapter. If resistance is below 3.0 ohms, continue to the final connection check. If it is not below 3.0 ohms, repair the open or high resistance and verify. The last step is a full connection integrity check before condemning anything expensive. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect connector installation, locks, corrosion, water intrusion, weather seals, bent terminals, overheating from poor contact, push-back terminals, spread terminals, and terminal tension. Repair anything you find, then reconnect everything fully and make sure the locks are engaged. Erase codes, operate or test drive the truck under the conditions that run the monitor and set the fault, then read codes again. If P0303 returns after those checks, replace and program the PCM, then verify. If it does not return, the wiring or poor connection issue has been repaired. Keep verification separate from testing. After any repair, clear the code, reproduce the captured conditions or monitor gates, confirm cylinder 3 no longer shows excessive misfires, and confirm the code stays gone. The takeaway is simple. Prove the misfire is active, separate fuel, spark, mechanical, and connection faults in order, and do not jump to a part before the test path points there. For more diagnostic training, visit stepdiagnostics.com.